Hi, today we will discuss applications of Newton's second law of motion. Here, these two masses, this mass is m1 and this mass is m2, and here m2 is greater than m1. Calculate acceleration of both the blocks and tension in a string. So here, first you draw the free body diagram of mass m1 and mass m2. First you draw the free body diagram. This mass is m1. So weight m1g downward and tension T upward. So here m2 is greater than m1 means m2 body moving downward direction and m1 body moving upward direction. So here m1 body moving upward direction, that is m1 body having the acceleration A is upward direction. So apply Newton's second law of motion. What is Newton's second law of motion? F net is equal to mass into acceleration. What is the net force? Upward, because here the body is moving upward direction. So upward force is greater than the downward force. So T minus m1g is equal to m1 into A. This is equation number 1. Next, similarly, draw the free body diagram of m2. So m2 free body diagram, so this one also m2g downward direction and T is upward direction. So m2 body moving downward direction. So the acceleration of m2 is in downward direction. So what is the equation for m2? M2, because m2 body moving downward direction means downward force is greater than the upward force. What is the downward force? m2g. What is the upward force? Tension. So here m2g minus T is equal to m2 into A. This is equation number 2. Adding these two equations, plus T minus T cancel. So m2g minus m1g is equal to m1 plus m2 into A. So from this, acceleration A is equal to m2g minus m1g divided by m1 plus m2. This is the acceleration of these two blocks. Means the acceleration of m2 is in downward direction and the acceleration of m1 is the upward direction. Now calculate tension. So substitute this acceleration A value in equation number 1. So what is equation number 1? T minus m1g is equal to m1 into A is the equation number 1. Substitute that acceleration here. T minus m1g is equal to m1 into A is m2g minus m1g divided by m1 plus m2. So from this, write T is equal to m1g plus m1 m2g minus m1 square g divided by m1 plus m2. So here LCM is m1 plus m2 is LCM. So now here m1g into m1 plus m2 plus m1 m2g minus m1 square g. So here T is equal to m1 m2g. So this is m1g, m1 square g, m1 square g plus m1 m2g, m1 m2g plus m1 m2g minus m1 square g divided by m1 plus m2. So here plus m1 square g minus m1 just common. So T is equal to 2m1 m2g divided by m1 plus m2. This is the tension in a string. Once again, so here two bodies, this body mass m1 and this body mass m2. In the question, m2 is greater than m1 is given, means m2 body is heavier than the m1 body. m2 body moving downward direction and m1 body is moving upward direction. Draw the free body diagram of m1. So for m1 free body diagram, m1 is downward, t upward, because m1 body is less than the m2. So that's why m1 is moving upward and m2 is moving downward direction. So upward force is greater than the downward force. So T minus M1G is equal to M1 into A. So here M2G minus T is equal to M2 into A. So from this you calculate acceleration A is equal to M2G minus M1G by M1 plus M2. Substitute this A value in equation number 1, then you will get tension. What is the tension? T is equal to 2M1 M2G by M1 plus M2. Suppose here in the question m1 is greater than m2 is given, then what is the acceleration? A is equal to m1g minus m2g divided by m1 plus m2. Tension remains same, that is 2m1 m2g by m1 plus m2. And if both body masses, if both bodies are same, that is m1 and m2 both are same, then what is the acceleration? Acceleration A is equal to 0.